Okay, guys, the next one is called Peter Forth, and I will present 400 megaForthWords per second. 400 megaForths per second. So how can we do that? We can do this with, let me see, with this chip. This is the MilkV board, model Duo, and it has a RiscV on board. This RiscV chip is able to do 1 gigahertz. It has a USB-C on the top as input and also as power. And it has a connector for a camera, for an AI camera, and an SD card connector here below. So this board runs Linux, sorry, and you see there are different models. The one I will show you today is a 64 megabytes of RAM and has the processor CVTech 1800. There is another CPU with 250 megabytes of RAM, and it has the CPU SG2002. These CPUs, both of them, have internally a TPU. This TPU is a trillion operations processor and is used for AI and for the digital camera interface. The board that continues is from the same family and has 500 megabytes of RAM, also 1 gigahertz RiscV processor, but includes also an ARM chip. So it has 3 chips on board, plus an 8051 MCU, a very small CPU, and the TPU for the machine vision or artificial intelligence. This port is also available with Wi-Fi and with a memory of 1 gigabytes eMMC, like a solid disk, but directly below the board in this space. And this board has also an Ethernet connection. All have an Internet access, but this has the connector on board. Here you see a picture of the 256 megabyte model. So you see there is 1 gigahertz RiscV, 700 megahertz RiscV, so 2 cores, an ARM chip of also 1 gigahertz, which can run Linux or Android, a TPU, this is for the camera, the TPU, but you can run also TensorFlow inside, and a small 8051. This is the RAM. The RAM in this port is 250 mega. There is no 64 megabytes. So here is a table with the comparison of the different models. Duo are this first one, and the other one is the 500 megabytes, also called Duo, but there is a mistake here because this one is the S model. And again, static RAM, A53 1 gigahertz Cortex CPU, very, very fast. And both of these CPUs have the RiscV processor. The architecture of the board includes GPIO I think we have over 20, 23 or 25, depending on the board. There is an AMBA bus that connects each peripheral and where the processors share memory and share signals. Here you see the DDR, dynamic RAM controller. Sorry, and it's very important to say that these are 64-bit processors, and the AMBA bus is also a very large bus. So information runs at very high speed inside this chip. Both processors have the video subsystem, and there is an audio subsystem also for intelligent voice and speech recognition. Codecs, the processor includes a codec processor inside the TPU, and the many peripherals we have on board: USB, SPI, NAND, eMMC, and the MAC is the Ethernet connection. And what is missing? I think there is something missing here, but I cannot see it. And so here you can see the comparison of speed. This board at 1 gigahertz is almost 10 times the speed of the Raspberry Pi Pico, 2 times the speed of the Buffalo Linux boards, which are also very, very small and also very, very cheap. So, and what about Forth? This is what all want to know. I put up a GitHub page, which is called MilkV Forth, and you can download an image, because these boards work with SD cards. So you can download the image directly from this site and burn into the SD card. So you can start this board in a couple of minutes, and you will have on board a Pygmy Forth, a McRisp, and in future I will add other Forths we are experimenting in the moment. But this is for beginners, a great help, because you will not suffer like I suffered with this setup, because it's a very, very complex setup. I need to thank Mr. Young Shen, who is in the meeting, and he posted about the board a couple of months ago. It was, in fact, in December of last year. And he also has this wonderful GitHub with an eForth from Dr. Ting running on the Linux core, of the RiscV CPU. So you can download these images from his site, and you can talk to the GPIO of this chip and from Linux. This is a post you can read on the Facebook page of the Forth2020 group, and you can run the video. There is a video showing the board in function. And then here is Mr. Yongshen GitHub with the files. So this is another of my posts showing McRisp running also in the Linux. This is McRisp Quintus. And I was running here an SHA algorithm and trying to get some benchmarks with MilkV. So go to the Facebook page and watch this post and the other ones, also from Peter Jakaki. Tony left. Tony is not in the meeting today. I wanted to have Tony and Peter Jakaki, but they could not make it to the meeting. And I think we will need to make another one, so we all three can explain the group together what we are doing with the board. This is Peter Jakaki post where he tested primes, a primes algorithm, a primes benchmark, and he tells me it runs over 400 megawatts of force per second. We still don't know exactly the number, so we'll stay at 400 because this is a huge number, and this is also what we are expecting the board will deliver. Maybe with the core A53 of ARM, it makes even faster primes. So one particularity of this board is that you have two cores. One core can be running Linux, and the other core is running RTOS. RTOS is a real-time operating system, and this RTOS can be programmed directly from Arduino. So this is simple for someone who wants to run real-time interfaces. It's simple to program and very practical. You only need a USB interface. You plug your board in, and you can download the code as it was an Arduino. It's simple as that. And you can use all the libraries, or almost all, not really all, but most of the libraries of Arduino will run without problem. Here you see an example connecting some pins, and the pins are the same as on the Raspberry Pi 2040. The size of the board is exactly the same of the Raspberry Pi 2040 of the Pico, and the power supply is very small. It doesn't consume very much energy, even at this high speed, even at 1 gigahertz. It stays at under half an amp. And here you see the SD card. The SD card is always necessary, except you have a larger board with the AMMC, where you can save your operating system into the electrical memory. So, but this board has also machine vision and a parallel camera interface. This is what the TPU is processing, and you can use YOLO to detect, to make robot vision, for example, obstacle avoidance on robots, counting objects and object recognition for the industry, for example, quality control. You can reject bad parts, and also gesture control to control equipment. You can make gestures, and the board will recognize what you show at the camera using YOLO, for example. This is how it looks like with the camera. This is the size of the whole system compared to a mouse. So you see it's very portable, it's very It's very small. You can install in robots very well. And really very practical. This is the larger board, which has an MIP interface. It can run 5 megas video quality at 30 frames per second. The cost is very low. It's under $10 or near $10, this larger board. And the larger board has 2 camera interfaces. Also a large GPIO on both sides. And both cameras have the MIP interface, and they have also an audio interface, Wi-Fi possibility. This is an extra, or Bluetooth. Both can be added. This is the web page of MilkV. I have this carrier board for my small board, which adds the Ethernet and which adds the 4 USB connectors and a reset button. We are going to the conclusions of this talk. I would say this is not a beginner board. Documentation is confused. I would recommend a beginner to stay at ESP32, Raspberry Pi 2040, Raspberry Pi Zero, Arduino, whatever you know and where you are happy. It's a good choice. This is more advanced. This is a board that needs a lot of experience, and you need to fight very much with documentation. At the point 3, I think RiscV is an amazing CPU and rivals the best MCUs in the market. And I think RiscV keeps winning support every day. So this is why I entered into this MilkV experiment. The price, these devices are very cheap, from $5 to $10. So if you want to try it, you will not break the bank. And it has a performance to price ratio really remarkable. Another thing, you can make a full Linux computer for that price, adding an intelligent camera, a TPU, and also Arduino input and output. The question is, can you work with this board bare metal? I am saying yes, but it's still a long way. And I do not think it's really necessary. So you can work bare metal, but you won't have Ethernet, for example. You won't have USB. You won't have access to SD card because it's complex. You need to have access to SPI. This is why I would say no to bare metal, except you have working bare metal on the secondary processor, and you still have control over Linux. In that case, wonderful. You run bare metal for high speed, and you communicate with the other board with Linux that communicates to the world. In that case, fantastic. If you are running bare metal and the first processor, I would say not. And here you see an example how to build your own portable computer with this small board, just a few cables, and in a couple of minutes, you have a portable computer, a small Linux portable computer that can run on batteries. This is something the Raspberry Pi cannot, because it's so power hungry. But this little board has not this problem, and you can run for long hours on battery, on a small battery, because the requirements are less than half a watt an hour.
Just
So,
half. What's her name?
so
What's her name?
there are many YouTube channels, and there are many videos showing the board. I recommend the Andreas Spies channel, which has always excellent professional reviews, and he's also part of our Forth2020 group. So you can address him and ask, and Andreas will also always answer. And watch this video, which is I posted on the group, so you can always get the video to really fast. You will find it really fast. So this is finito. This is the end. And please ask me questions. I am happy to answer. Oh, sorry. Sorry. This is the end of my presentation. We go just in a minute to the questions, but let me show rapidly. This is live. This is live working board. So you see, I have the force running in the board. I have the USB connector here. This is my USB. And here I have a TTI that works on my terminal. Let me see where my terminal is. Is my terminal here? Yes, it is. So I am here with the force. This is a small force I installed on the RTOS. I will just show you an LED lightning, because today we have a large meeting. I can't show you everything because it's a large, it's a giant amount of information. So let me shine one LED. So LED on. Let's do a LED on. So you see here the LED on. I will put it to off. And this is a MilkV force I am working on. And let's see if we can make the screen off, the LED screen. I think it's not in this version. No, it's not working in this version. But we will show this in a future meeting together with Tony and with Peter Rakaki, so they can also show their boards. And I will show you all what I can do with the different kernels. I am just talking to the secondary kernel, and I am not talking. I can open a SSH connection to the Linux kernel at the same time, because both processors are running in parallel. And now I am really finished, and I'm happy to answer your questions. If anyone has a question, please go ahead.
Are you also planning to run GFort on it?
GFort would be too heavy, in my opinion. GCC does not work in this board because it's small. It's 64 megs. And you can install Arch Linux in the board, and in the larger, the 256, which is the one of Tony Leff, and also from Peter, it should be possible to install Ubuntu. And maybe we can install GCC, but I think it's very complicated to do so.
Okay.
I have installed, I think we can install without problem the pForce. I have installed PygMeForce, which runs on Python. The board has Python on board, my board. We have TCC, the compiler, the small compiler, and a lot of tools inside, a lot of tools, but not GCC because it's so heavy.